Apparently, we are microphoned up and recording and stuff, so that's all awesome. Develop slides. Do feel free to join the conversation using the hashtags and stuff. There's a Facebook page and all that gear as well. Please feel free to rate me afterwards. It means I'm more likely to get to talk next year if I get a good rating, so do feel free to do that. There's an app that will help you do all of that stuff as well. And right, here we go. So this is my talk. It's how to not fail at software engineering, or stop. If you commit that, you will have to live with it. So who am I? I'm Alex Darby. I'm director of a little company called Darbotron. I also help run a co-working space called Arch Creatives in Leamington. I've been programming and designing since 1996 specifically, but I'm into late 90s. I shipped lots of games, and I was a founding member of Freestyle Games who made DJ Hero. It's sort of old now, but that's my main claim to fame, I guess. I've got a broad programming experience. I've done everything from sort of low-level stuff to, gameplay, things, physics, basically everything. And I've sort of ended up just moving from pillar to post as stuff needed doing at the various companies I've worked at. I guess you could call me a technical generalist, but I don't really care one way or the other. Yeah, that's that, I guess. So I guess the title's a little bit weird, and that's deliberate. I've chosen to say how not to fail at software engineering because it's a complex topic, and I wouldn't trust somebody who's telling me that they could make me succeed at software engineering. So I'm not going to try and tell you how to succeed because I don't think that is a solvable problem. Certainly not in a 45-minute talk. I think the best we can realistically achieve is to share our knowledge with each other, to share our experience and avoid communal failure by listening to each other's previous mistakes and trying to avoid repeating them. So a sort of prelude to this is that the ultimate goal of all our workplace processes is that we want to reduce the risk in a project, right? If a thing is costing us a certain amount of time, right, or money to start with, time is money, so I use those things interchangeably. We've got complex and also likely to change things that we're working on. Games are like that, right? So they're complicated to make, they also change a lot. We've got very conflicting software engineering goals. We sort of need enough architecture to afford us some robustness and hide the bits away that we don't want people to break easily, but we've also have not so much architecture that if we need to change it all, it doesn't cost people a lot of time breaking their brains and cause lots of problems with sort of broken abstractions if we do need to change it. These are big picture problems though, right? And we've inspired lots of books with them. There's whole development methodologies built up around how to solve these particular problems. They're sort of big picture things, right? But we can still reduce risk in other ways. So that's what this talk is sort of about, really. It's a medium-sized problem that I'm trying to address with this talk. It's not the massive, how do you make your processes work? It's not the small, how do we optimize this to make it fast enough sort of problems. It's the middle stuff. So since I left Freestyle in 2010, I've done a lot of contract work. I mostly get parachuted into games that need to ship in the next couple of months. And the funny thing is that they almost never have big problems in the high-level architecture because you iron those things out early on in the dev cycle or they don't get ironed out at all, right? There might be problems with optimization, but there are people whose job it is to fix that, and that's just a handleable problem. Most of the problems, most of the man-hours involved in bug fixing and so forth are spent on the same daft little problems that nobody ever meant to put there, that have just accumulated throughout the project. And they sort of build up to toxic levels and get to the point where everybody sort of ends up fighting the same battles again and again and again. And this is literally the last 4 projects I've had have all had exactly, 3 of the problems were exactly the same, and they're all completely avoidable. And that's what this is to talk about. It's to talk about meso-level problems, right? Not the micro, not the macro, the day-to-day, I'm typing some code and I'm a programmer problems that we deal with, right? And so how does it happen? How do we end up with these problems? Well, it's accident, right? Everybody's busy. We've got a hit-driven business model. In terms of our time and how the time's spent on products we work on, we're effectively under constant deadline pressure, and features will generally take priority over fixing technical debt, right? So if you work really hard to get some new feature in, thinking it's fine, we'll fix it as soon as this little milestone's out the way, you won't fix it. You're going to just live with that stuff, right, for the next 6 months or the next year or however long. Like at Freestyle, we had when I left, it may well have changed since, there was font rendering code in there that was literally the first ever test font rendering code we checked in. And it had been there for 7 or 8 years, and no one had ever really needed to change it, and because you could live with it, we just did, right? So I guess that's the biggest takeaway, ultimately. We'll get to that on the next slide. But the biggest takeaway, which I don't know if it's actually written on here specifically, is, if you check it in, you will have to live with it, and not just you, everybody else on your team will have to live with it, right? And possibly the most important person to consider at that is future you will have to live with it, right? And future you will judge you. Future you will despise you and take your name in vain and call you all kinds of names. And you want to avoid that, right? So I guess what I'm trying to get towards is this minimal viable software engineering. So it's not, how do we attack design patterns? It's something a bit smaller than that. They're everyday little principles to avoid writing bad code. And I guess the kind of thing that you want to actually bear in mind when you're doing code reviews with people, like rather than going, you didn't put enough spaces around your curly brackets, or you don't do a cast like that, we're talking about the actual problems that happen in code. The things that make your code less robust or harder to change or more likely to cause other people problems in the future. And the aim for it is for these sort of rules to be, they're not rules, that's the other thing I want to say. They're more heuristics, right? None of this stuff is prescriptive. You can't say, do this and your code will be awesome, and don't do that and your code will be 100% awesome, because some of these things are a little bit more shades of grey and you sort of have to take them on a case-by-case basis. But I'm hopefully going to give you a good feeling of when those cases drop in and out. And the main thing is just to proactively prevent cumulative issues, right? And they are horrible when they happen. So the caveat is, this is more of an idea than a thing that I've codified completely. I've got a start to it, and I want to encourage you to ask questions, or if you've got specific observations that I haven't mentioned about something I'm talking about, feel free to sort of pipe up. And if I'm going to deal with it, or I think that we can leave it to the end and just have it as a question, then I'll sort of encourage you to do that. But generally, I'd like it to be as two-way as reasonably possible. We should have plenty of time for Q&A. I'm hoping to have plenty of time for Q&A, because I think this is a thing for discussion rather than a me telling you how to do it problem, right? I mean, that's ideally part of that is me telling you how to do it, but hopefully it'll be a two-way thing. So we've got the guiding principles. The fundamental guiding principle is to take responsibility for your own code, right? Once you commit, you have to live with it. If you could take 5 extra minutes or an extra hour and just get rid of the little things that you're not happy with in your implementation, or just go around it and give it a once over, right? So quite often you work in multiple source files. The last little bug that you iron out, you're like, yes, finished, check in, go home, right? That's standard. That's probably not how things should be done, but that's standard, right? So once if you've got multiple source files, chances are there's a change in one of the other source files that you weren't 100% happy with, but you forgot because you're so happy you fixed the thing that you needed to fix and you've checked it in now. So the first thing is just take responsibility. Don't do that. Have a good look and make sure you haven't left any of these little niggly things in. We want to maximise the ease of understanding for other people, because if you're working in a team, and even if you're working just with yourself, right, future you and all of your colleagues are going to have to come back and understand this code at some point. So you want to make it as easy as possible to understand, because statistically that will reduce bugs, right? We want to make it easier to change. We want to make the code so that people don't have to fight leaky abstractions and find the same bit of code dotted all over the place to fix it. If it's fixable, you want to try and fix it in one place. And that comes down to ease of debugging as well, right? If there's a problem, you want to know exactly where it is, not some variable that might be changed in a billion different places. You want to know where it is, right? And you want to go straight there. We also don't want to reduce productivity. I'm not suggesting a bunch of rules that you sit there and go, oh my God, have I done it right? Right. These are just little things that might take you an extra 2 or 3 minutes per task, right? And because, I mean, at the end of the day, typing's not the bottleneck in programming, right? Generally, typing isn't our bottleneck. So if you've got to type a bit more, or you've got to, open an extra source file and do that sort of thing, you shouldn't avoid doing it just because you can't be bothered or because you're stressed out and you don't have enough time. So the first thing that I'm going to ask you is, what is the most dangerous thing in your code base? The single most dangerous thing in every single code base, in any programming language. Does anybody want to offer an opinion? Yeah? That's pretty dangerous, but it's not the most dangerous thing. Duplication is also dangerous, but it is not the most dangerous thing. Anyone else? This is just my opinion, by the way. This is the most dangerous thing. That assignment operator is the most dangerous thing in your code, right? You can dereference a null pointer perfectly happily, but if you assign something to it, that's when it crashes, right? So statistically speaking, you want to minimize the number of equal signs in your code, right? That sounds like a ludicrous thing to say, but it's true, right? If you minimise the number of equal signs, then you minimise the number of lines of code that have got bugs in them, right? Potentially. Right? It's a weird way to look at things, and it might actually be logically untrue, but I think that it's a valid way to look at the problem. And the reason for this is it comes back to, as this man correctly said, duplication of code, but we'll get to that on the next slide. So mutability. Mutation is itself inherently dangerous. That's the thing that will break your code, right? And if you're dealing with threading and stuff, mutation happening from different sources, that is what will kill your code generally, right? So in order to deal with this problem, you want to maximize the locality of mutability, which means actually really what you're trying to do is minimize something, but because of the way that that's phrased, it sounds wrong. You're trying to minimize the number of places where things change in your code, down to ideally one line. And I think this is the best argument for accessors, really. Like, when you're taught about object-oriented code and encapsulation and stuff, people are like, do accessors because it's the correct way to do things. And you're like, that's ludicrous. I don't want to write a function to access a member variable. And that argument for it is actually pretty nonsense, in my personal opinion. Like, encapsulation is important, but what's more important is knowing where that thing is changed and being able to trace where it's changed, right? So if your argument for not bothering with a getter function is that you don't want to have to type the brackets, or you might as well just put the raw variable in everywhere because you can. The bottom line is if you do that, it's fine. It's essentially the same code, right? Fundamentally, that will end up running at the end of the day. But if you've got thing plus dotted all over your code, or just something equals thing, you can't track it down. You can't just put a breakpoint in a function. You can't put a thing that logs out your stack in a release build in that one function that you know is probably breaking it, and find out where it was getting called from, because it's been touched all over the place. And yeah, you can put a hardware breakpoint, but it's just a bit easier, I think, personally, to know this thing is changed in one place, therefore this place somewhere, calling this place is the problem, right? So it reduces your problem from a haystack to like a fine point, right? So statistically, my personal opinion, and again, I'm not saying I'm definitively correct on this, but I think trying to make sure that the amount of places where state can change, minimise that as much as you can. And this is a day-to-day thing, right? And it's a principle of the whole of this sort of minimum viable software engineering. So the next step, and this comes back to the previous one as well, really, if you think about it, we should never write the same line of code twice. So if you're writing thing plus more than once in your code, don't write thing plus the second time. Just do increment thing bracket as a function, right? Because then you know that if you've called that, the actual plus+ing, which effectively is assignment, right, is happening in a defined place that you can track down and it's easy to find. And you should abstract anything that's likely to change. And again, these are sort of quite broad, wide-reaching things that I'm sort of exponing, if that's even a word, that I'm an exponent of. But you only need thin abstractions to make your code easier to change in future. Like if you've put, like new's a classic example of it, right? You can overload the new operator, right? And that's perfectly valid, like in C++ at least. You can overload new, and that's fine, and you can come along afterwards and say, oh, memory management isn't working in this class, we've used new, we'll just overload new for that class, and that's fine. But when someone reads through that code, all they see is new. They don't see that you've overloaded the new operator unless they go and look for it. So if you put a function that is create new thing instead, that person instantly knows that function's where I need to look. And even if to start with that function just calls new inside it and returns the object, then you know that if you want to come along and replace it with a pool later or any kind of other number of allocation strategies, it's easy because it's hidden inside a function and you don't have to worry about where it's connected. And also it tells you what's happening. I mean, obviously new tells you what's happening, but if the function says create a new one of these things, it's a bit easier for people to sort of just read it and make sense of it as if it was natural language. So state. The next thing is state. Now, the number of code bases that I've parachuted into and found some horrible bug that we don't know how to fix this, or, would you have a look at this, Alex? And there's a 1,000-line if-else statement somewhere, right? And nobody writes a 1,000-line if-else statement, right, from scratch. Nobody sits down and types out, going, oh, this is brilliant, I'm going to do a 1,000-line if-else statement. I've got 10 different things I need to worry about. I'm going to put them all in, because the thing about if-else, as we all know, right, is they're dangerous and implicit. Like, if you're looking at some code in an if-else that's like 6 or 7 clauses down, you've not only got to worry about the test that's in your block, you've got to worry about all the tests that failed before, any weird side effects that might have happened as a result of those tests. You just don't know what that code is, and if it's not your code, or even if it's your code from a year ago, you're not going to be sure about what happened there, right? So we should be explicit about state. Don't do if tests that have got, like, if thing is greater than stuff and bool equals whatever. Don't do that. Just somewhere, set state variable, find an enum, look at all the different possible outcomes, set them in one clean bit of code that tells you exactly what that thing means, and test those with a switch statement. Even if that's all you do and you don't do anything cleverer, that's still a million times easier to read, and it's more stable. It's harder to break, right? And don't use bool, right? Bool is a terrible idea, right? Unless you know a function, for example, is only ever going to... So, like, is this button pressed? That is a fine example of when you can use a bool, in my opinion. Anything else, you should use an enum for it, right? Because at the very least, even if it is only going to be a bool, when someone tries to understand some code that's got a Boolean value in, they have to not only, even if your Boolean value is named very, very sensibly, they've still got to work out what the logical negative of it is if they read a state where it's false, right? And that isn't always an obvious thing, right? If you use an enum, you can say exactly what it means when it's true and exactly what it means when it's false, and just return two different enum values. And when they read the code, they can tell exactly what you meant that to mean, and that not just this thing is true or this thing is false, right? Because true and false they're pretty arbitrary distinctions for a lot, even though there might only be two states. The actual meaning of true or false might be quite wide from the point of view of the person reading your code. So, I mean, enums is one of my... This comes back to the top point, is you want to be as implicit as you possibly can in all the code you write, because by being implicit, explicit. By being explicit, you statistically reduce the likelihood of other people misunderstanding your code and yourself misunderstanding your code when you come back to it. Right, so the next bit... Ooh. Okay, no, that's fine. We've still got loads of slides. I was afraid I was going too fast. Responsibility in interfaces. So, again, dropping into code bases that are near the end of production, one thing you see all the time is one class that's sort of central to the game, and it's grown, and it's grown, and it's grown, and it's grown, and you've got tons of variables that belong to completely different logical responsibilities of it. All of the code in that class can access them, so although they're theoretically encapsulated, they're not really encapsulated, because that class is responsible for something like a quarter of the logic of the total game, right? So that's a really bad thing, right? If you ever get to the point when you're about to add a second responsibility to a class, don't add a second responsibility to a class. Nobody ever wrote a monster class in one go on purpose. It doesn't happen. It's like the if-else statements. It's a cumulative problem that people have accidentally added to because they're busy, or because, you know, someone was breathing down their neck for an instant fix for the latest build or whatever. So by taking responsibility for doing that, the first time you should do it, it instantly means that you're not living with that stack of cards for the rest of the game's development. And when I say a stack of cards, it's not like a house of cards the right way up. These sort of problems are a stack of cards that way up. So you've got a wide problem sat on top of a single point of explosion at the bottom, right? Well, sometimes it can be that bad. So really think about interfaces as well. So when you're separating that responsibility, again, prefer enums to bools, right? Be explicit in everything that you do. And don't use sensible names for functions, quote unquote. You should, like, I think, you know, when I used to run a team, I used to be like, why not just say exactly what the function does? Typing the function name is not what's costing you the time in your job. Just say, get this thing from this thing and do it to the stuff, if that's what you actually mean the function. If there's no obvious way to explain in 3 or 4 words, just write a short sentence that explains exactly what the function does. I mean, sure, you've got like a slight overhead from then on of renaming the function if you change what it does, but search and replace is pretty powerful, right? It doesn't take you long to do that. It's not an argument for not doing it, in my opinion. So the next thing on top of that, with these interface problems, is the implications of how you, implications of params for. Okay, so I've obviously left the end of the sentence off, but luckily my notes tell me what I was talking about there. It's sort of a subtlety, and that you don't really get in languages like C# where they don't have const and they don't have a distinction between pointers and references. But in C++, when you're declaring the interface to a class, if you say to someone, if you use pointers, right, there's nothing wrong with pointers. I like pointers. Everybody likes pointers, right? They can be dangerous if you are indiscriminate and not careful with how you use them, as all things can in programming. But if you say, my function takes a pointer, what you're basically saying to people who call your code is, I am going to take responsibility for checking the null pointer that you pass me to see if it's null, right? And if you take a reference, you're basically saying, it's fine if you're handling pointers externally, but you're going to check that it's valid before you pass it to me, right? And that little thing, I mean, sure, like, there's an argument that says that references are safer in some way, and they're not really. Like, it's pretty easy to make a null reference if you try. But just by that implication, by saying to people, declaring your intent with your interface that you expect them to worry about whether it's valid or not, you're instantly sort of drawing a line in the sand when you write your interface that helps them understand what your intent was with your code, right? And that's a very subtle one, but you'd be surprised how often people just take pointers and don't check them or whatever. So it's a thing to bear in mind. Okay, so one thing that I've somehow missed off that slide, but is on my notes, is when you're thinking about this separation of responsibility, a really valuable thing to bear in mind is, and it's something like people, when I first heard of the model view controller, I was like, what the hell's a model view controller? But it's surprising how often that comes up as pretty much the perfect way to abstract things in the game context, right? So even something as, it was originally invented for UI, right, pretty much. But the model view controller way of looking at things, your model, which is the data that underlies the thing, your view, which is how your game represents that, and your controller, which controls how the model changes, right? Those are your three bits of it. That works for pretty much all of the bits in the game. You've got a character controller. A character controller, if you want to make your character controller code better, right, think of it in model view controller terms. You shouldn't have a character physics code that touches the character physics code, my opinion again. Character physics code shouldn't only think about animations, right? If you've got a character-driven game, the animation should be handled by a separate system. Like you've got a model, which is your physics. You've got a view, which is the animations that are representing to the player what the physics are doing, and you've got your controller, which talks to the physics, right? And pretty much anytime you're trying to work out some sort of separation of responsibility with game stuff, you should consider these problems because I've written lots of games. I've also been involved in lots of games, and the number of times when I've found they've got problems with the character controller, and having the animation and the physics in the same set of code just means that it's a lot harder to work out what's going on at any given point because all of your state tests become combinatorial, right? Instead of a straight bunch of am I on the floor, am I touching a wall, am I running, or whatever, that you have for the physics, you've also got all of the what's the animation doing as well at that point, and suddenly all of your tests are like doubled up or tripled up, and it's just ugly and difficult to work with. Whereas if you just separate that out into a separate file and have the animation system look at the physics and work out what it should be doing, it can be a little bit harder to get it working perfectly, but when you do, the two systems are discrete enough that you could just chop one out and replace it with something else. But also, each one's simpler because there's less tests, there's less different ways the states in that object can get out of sync in ways you expect them to. So, I mean, one thing that people might have noticed is that a lot of what I'm talking about is basically similar to defensive programming in its principle. The whole, like, if you get a pointer, assert that it's not null and that sort of thing. And that's true. Like, this really is sort of a defensive strategy, but wide, rather than being just, asserting stuff and proactively trapping problems before they happen. It's a just try not to introduce those problems in the first place kind of problem, kind of solution to the problem. So, the next one, and this is one of those I guess it's one of those holy wars that rages around the singleton thing. I imagine people have noticed it says singleton already. I'll get to that in a minute. One of the big problems with code bases, especially when you're popping into them at the end of the game, is that the life cycle of objects in games quite often aren't explicitly controlled. Certainly, so like a lot of the games I've worked on in the last few years have been ports of Unity games from PC to console. And, or from sort of PC/iOS to real released iOS, right? And the funny things are that the situation in which you develop your game and the live sort of platform from it can differ in fairly wild ways. And if you're living with code that came up from a prototype, and someone again wrote a bit of code that was supposed to be there for about, a few weeks for a milestone, and you're still living with it, and then whole chunks of your code are sat on top of that, it can cause real big problems towards the end of the project. And the reason why I'm saying control lifetime explicitly is, one of them is you need to manage system resources when you're making games. And it's more, I guess it's more important in sort of the AAA space where you're managing your own memory and you've got to worry about every tiny bit of it to make sure you can fit as many textures in and as much animation data, and that you're packing as much as you can into the space in the machine. But managing system resources becomes much harder if you can't guarantee the initialization and shutdown order of all the main components of your code, right? So, and this leads us on to the next section. Lazy initialization is super, super evil because what it does is it not only, first of all, most objects that are lazy initialized are global in the first place, right? So they're by their nature, they're accessible from everywhere. But if they're lazy initialized, they're also accessible from any time, which means that if someone writes some code in, say, the loading screen that wants to find out a small setting so it can display the right kind of loading screen, suddenly a big chunk of your game that shouldn't be being initialized till just before the main menu gets initialized is suddenly being initialized in the first few frames of your game booting, right? That can cause massive problems. And if that's happening towards the end of a project and you've got a load of other stuff sat on top of it like a stack of cards, it can cause real big trouble. So I guess this is the first time I'm going to pull an anecdote out of the... I know, actually, I'll do it on the next slide because it's more pertinent to that, but it's fine. So yeah, a lazy initialization is super evil, and it does give you convenience, but it really does give you at the expense of control of your system and how your code starts up, how your code shuts down, what stuff's in memory, what stuff isn't in memory, and it gives the control to people who accidentally call in that code. So one of the worst things I've ever seen for this is if you're looking for sort of tutorial Unity code and people are saying, how do I do a singleton? You'll see pretty much exclusively people are saying do lazy initialization, and it's fine. And I guess a lot of textbooks suggest it as a good idea because things don't exist till you need them, right? And then they suddenly exist when you do need them. But it really is a convenience. That solves a convenience problem, not a technical problem. And you end up in situations, for example, a game I worked on last summer, someone had written had a settings file that existed since the prototype, which synchronously loaded an XML file from local file storage when the singleton was constructed, right? That's a terrible idea in the first place. First of all, don't load files in constructors. Like, Bjarne Stroustrup might say that's a good idea, but it's a terrible, terrible, terrible idea. Never do it. Especially if it's a constructor for a static object that exists for the scope of the game. Like, you're just asking for trouble, right? You want everything that happens to allocate large chunks of memory or pull stuff in or pull stuff from outside or get rid of stuff. You want to know when that's happening. You want that code to be explicit because you don't want people to accidentally cause horrible side effects that can cause you bugs that will break your game. So the problem with this thing was this XML file contained all the data for the game. It contained the data for how the front end was set up, the number of levels, the number of missions, the settings for all the characters. But it also contained the settings for like how many splash screens there should be, what textures they should use. People had just gone, oh, that's a convenient place to put the setting I need, I'll put it in there. And so this object was getting initialized earlier and earlier and earlier and earlier down the path of things to the point where it was initialized in the first frame. It did a bunch of static loading, synchronous loading, and then the whole game was reading this XML data, setting itself up once and never changing itself again, which again, none of that stuff's a bad idea at the time when you write it. But then we come to a couple of weeks before release and they're like, well, what we really wanted to do was put that settings file on an Amazon server and download it and update it whenever we feel like it. I'm like, but you're loading it synchronously in a static constructor that gets called in the first frame of your game. How on earth do you expect to fetch that off an Amazon server? Like, that's impossible. So we had to basically, I mean, again, the solution's not that difficult, but you can't fix the game at that point because the whole game is this stack of cards down to this single point that's unfixable. What we had to do was just add an extra state to the game that just talks to the Amazon server and replaces the local file storage file before the game even starts up. What they wanted was a system where they could live update the game and have the game refresh itself and change all the levels and stuff in real time. And it's like, that's just not going to happen. We've got 2 weeks, that's 2 months worth of work, right? Every system in the game hangs off this one thing. But the person who wrote that class in the first place didn't do anything wrong when they wrote that class in the first place. It was a cumulative comedy of errors of 9, 10, 12, however many months of development where people had just done the easy thing, added to a bit of code that was already there, and nobody did anything wrong. But because nobody took the responsibility for changing something that looked a bit suspicious, it caused this massive problem, which took me, in the end, it took 3 weeks to fix this bug pretty much on and off, which is kind of crazy for something that should be a simple, straightforward thing to do. So again, this leads us to this point about beware the singleton. Singletons aren't inherently evil, right? They're a valid way to solve problems. And, the design pattern of singleton is a valid way to design problems. You'll hear a lot of people getting really angry about them, a lot of people defending them vehemently, and I'm ambivalent, ultimately. As long as people aren't doing ridiculous things with their singletons, like the people on this who'd used this code base, it's fine. But the problem with them is they do sort of encourage these degenerate solutions where, oh, there's a singleton, I can get at that from anywhere in my code. It's always there because the first time I call get on it, it initializes itself. Suddenly you've got a situation where everybody just thinks that's the right way to do it because when they look around in the code to see how someone else has done it, that's how everybody else has done it. And so suddenly, without anybody ever deciding that was the right way to solve a problem, it's become the way that everybody solves a problem by sort of default. And so this is a thing to be really aware of. If you're making a game by yourself, it's not a decision that obviously will cause you trouble. But if you were trying to do this, save games, for example, if you're putting a Unity game from PC to console, suddenly your save game, which is perfectly valid on a Unity game on PC, to open a local file storage file and just serialise something into a file in a function and just expect it to be done, that's fine. But on Xbox or PS4, you have to kind of ask the operating system to get you a container from user storage, and then you have to pass it a pointer to the thing to fill up the data with, and you have to wait for it to finish. There's no way to make that happen. Well, actually, I'm getting ahead of myself now. We've sort of got onto this topic of asynchronous is standard, should be standard. But singletons kind of encourage solutions from people that, through no fault of their own, because they're busy and because they don't have a lot of time and because other people have already solved their problems in less than perfect ways, they seem like the right thing to do. But then when you come to fix them later, they can be a real pain in the neck. And asynchronous operations are one of the biggest problems I have when I port games from PC to console, is that on a PC, you as the user, the writer of the code, have absolute control over what goes where. Well, give or take. Obviously, the operating system stops you from doing some things. But, you can open a file wherever you like. Within reason, you can save whatever you like to it. And it generally happens fast enough that if there's a one-frame blip while the save thing pops up on the screen, nobody cares, right? But when you get to console, you just literally can't do that. And if you're porting a game that assumes that all file access is synchronous, suddenly you've got to, when you're porting it, you've not only got to port the code, but you've got to add new states into the logic that expect to wait around for asynchronous operations to complete before they can continue. So your port goes from literally, with Unity, it's easy to port things. You pretty much fire it up, press the PS4 button, and it works on PS4, right? That's pretty much, is that pretty much that straightforward? But it's the getting it working in a way that Sony will be happy to let you release it that's the problem. Yeah. So synchronous file access, then it becomes your port problem. Your port comes from a problem of taking somebody else's code, which in an ideal world you want to have to mess with as little as possible because you don't want to add any new bugs to their code, trying to fix the bugs that they may already have in there. You don't want to, if it's stable and it's been released, you assume it's sort of bug-free. So you don't want to mess with it any more than you have to because you might introduce new bugs. Again, statistically, not adding bugs by not messing with the code, that's a good approach to things. But it can be really difficult. So we had, to go back to DJ Hero, the first DJ Hero game we did in 2008, it was the first game we'd ever done that was networked. And it had local multiplayer. And I was running a team of people doing the network code, and we were literally, we were running, we offered a sort of API to the main game code that was platform agnostic, and it let you do matchmaking and sort of open a connection to another machine and get quality of service probes and send data, right? That's what it did. And then the gameplay programmers were responsible for using that to implement a multiplayer game. So the problem is the game itself was relatively straightforward, but the front end, we thought, it'll be fine. If you do a front end, you're bound to have a stack of screens that just literally layer on top of each other like a web browser, right? That's the obvious way to do a front end. Everybody must do it like that. We'd never considered that somebody else might do it differently. When we came to actually help the front end people integrate the network code, so they were trying to synchronise these two people on different machines at opposite ends of the world potentially, so that they were always on the same screen and the selections always matched up. But their front end was entirely stateless. It was just massive bunches of if-else statements, right? And it was an absolute nightmare as a result of it, because not only was it a nightmare because it was stateless, but it was also a nightmare because it assumed everything was synchronous. And if you've got a system that already doesn't have state and you've then got to add asynchronous behaviour on top of that, it's just, it was horrible. I basically did 5 weeks of overtime hours in 6 weeks to fix that problem. That's the worst amount of overtime I've ever had to work in my entire life. I don't recommend that as a thing. Don't ever do that. It's awful. But, we had to get it shipped, so that's what I did. So the point about synchronous and asynchronous is this goes back to that taking responsibility for your own troubles and for future, you don't want future you to think you're an idiot. So it's really easy to write a wrapper around synchronous file access that makes it look asynchronous. It's a trivial thing to do. You basically say, call a function, and then the next function you just check if it's asked for the file access, and then the next frame you do the synchronous file access, and it goes, I've finished. From the code's point of view, it looks asynchronous because more than one frame has passed between the request and the data coming back. So the game code, then has to be written as if it expects that thing happening, right? Which means that when you switch to a thing that actually has an asynchronous call, it'll just work. But it's impossible to make asynchronous file access behave like synchronous file access. It's just, it's not impossible, but it would be a ridiculous thing to do. You just go like synchronous call, wait while the thing hasn't returned. You're going to get a pause for like X seconds and your frame's going to go off. If you're on a PS4, it's going to fail instantly because you're not allowed to have more than a certain amount of time between frames on the hardware and all sorts of stuff. So generally, don't do any I/O that's not. If your I/O is synchronous on the machine you're working on, just write a thin wrapper around every I/O function that you're calling that behaves asynchronously, right? And then when you come to port it to a machine that's got asynchronous code, your code will work. So that is important. We're not doing too badly. We've still got plenty of time for QA. Good. Okay, so we're nearly at the end. I've just got a couple of things. So if you're working in teams, this is my final aside before I sort of summarise and then ask you guys to give me your personal bugbears. So I find this sort of stuff, as programmers, the reason why I think this stuff's important and that I don't think it's ever talked about is because this is the stuff that we do when we're sat at our monitors and everybody else is getting on with their work. This is what we do, is this kind of problems are the problems we accidentally generate absent-mindedly when we're just sat there. I mean, I've done all of these things myself a million times. I'm not claiming to be perfect, right? But just by sharing our knowledge with each other, the simplest way to do that in a workplace environment is you don't have to have like vicious formal code reviews where you shine lights in each other's eyes and keep clipboards and all that sort of stuff. It just needs to be like once a week, sit down and talk to each other about your code, talk each other through your code. Like it's a good thing to do because even if it's not a formal code review where someone says your code is rubbish or your code's awesome or whatever, you're just basically putting more eyes over the same code base, and meaning that if that person's away on holiday or ill and the bug happens in their code, somebody else knows what's going on in it, right? But I found that a really useful metric, and this isn't just me that's found this. This is a bunch of my friends who've spread all over the world now. We all used to work at Codemasters pretty much once upon a time in the 90s, and we've sort of communally come up with this, so I can't take complete credit for this. And it's the WTF per minute metric, and what you essentially do, you've all read it by now, I assume, but what you do is when you're looking through someone else's code, what happens is you look at it and you're like, what the thing? And so what typically happens is you look at the code and they do something that looks bonkers to you. You notice that it looks bonkers, and then your brain makes sense of it and you're like, okay. So like that's a cancelled out WTF, right? So that doesn't count towards the total, because it means that you understood their code and actually it was fine. But for every non-resolved WTF, you sort of total those up and you work out how long you're looking at the code for. And it works out as being a pretty good code metric for how messed up or not messed up somebody's code is. And the good thing about it is it's kind of funny and it's informal, and it means that but you still have an actual score that you can show to each other, right? And so, management people are happy because there's a score that you can quantitatively say, this person has a 5 WTFs per minute problem, so we need to work on that, give them a little bit of help with their code or whatever. Okay, so in summary, the main points about this minimum viable software engineering thing that I'm talking about is it's really just about taking responsibility for doing things right the first time you do them, right? So instead of, everybody writes code I assume everybody writes code in broadly the same way. You get an implementation working, then you sort of tighten it up and make sure it's a bit more bulletproof, and then you kind of maybe get someone else to check it over, and then you check it in, right? But I'm sort of encouraging you to really take that responsibility seriously, because future you may hate you if you don't, right? So make sure you control where mutability happens. Don't ever duplicate stuff. Sort of the same problem as the first one in some ways. Like literally every single time you find yourself, even if it's writing code that's similar to code you wrote earlier, and definitely if you find yourself cut and pasting code, stop and write a function. Like that's the cardinal sin, which I forgot to mention earlier. Don't duplicate code. Be really explicit about everything, not just state. Be explicit about function names. Be explicit about meanings. Don't use bool, use enum, right? On average, it's better, in my opinion. Use a single state variable for all the mutually exclusive states of a system, and control the life cycles of all the objects. Right? Try and keep it to one responsibility per module or class. The second you add some state variables to an object that start to encapsulate some other thing than the thing it's already doing, make it a different class, right? Just do that. And always use asynchronous as an I/O standard for your code. And remember, if you commit the code, you will have to live with it. That's really like the main point, I guess. And the other things are what you should do to try and make sure that you'll be happy to live with it. So this is the bit where we stop and I say any questions. And it gets a bit awkward if you don't ask questions or provide opinions. So please do. We've got 5 minutes, so that's plenty of time for questions probably.
Just a quick question. When you're talking about using enumerations over using offsets, wouldn't something like an actual state machine be like one step better? Like you'll have like literal like separate functions that be called depending on the states as opposed to using.
So, Darren, right?
Yes.
Yeah, cool. It can be, but like, this isn't. I'm not trying to suggest like a one-size-fits-all problem. Like, so my personal way of writing code like that is I'll start off with, generally you'll have one flow through the code, one set of what you do. You'll realise that maybe it's got two different states and it'll be an if-else. When you go to a third state, you realise this actually is probably three mutually exclusive states. I'll do a switch. Once you get to a point where the switch starts to have complicated behaviour in the different bits of the switch, that's when you think maybe this should be a finite state machine. So I guess, there are, like I said, there are whole code methodologies that broadly deal with this sort of thing, but I think in the game industry we don't talk about it enough. Like there's extreme programming is the one that I would sort of point yourselves at if you're not sure. Like they advocate, they've got like a bunch of really ruly rules. It's sort of an agile methodology, and they're like refactor aggressively. Like every single time you go in your code, if there's anything wrong with it, fix it now, don't leave it. And like whilst I sort of disagree with the refactor aggressively thing, I very much don't, if you think you might need a state machine eventually, right, you don't necessarily need to spend the time, because the thing is a full state machine with like separate classes and like on-state initialize and on-state update and on-state shutdown and all that stuff, it takes a lot of time to write that class, and if you find you don't need it, you've spent probably half a day writing code and debugging code that you maybe didn't need to. So I would say always start from simple and work out to more complicated. As long as you refactor at the time you know that you should, rather than, oh, I'll leave it, it'll be fine. The refactoring's generally pretty painless because it starts off as one thing and gradually builds out into a more complicated structure rather than becoming a horrible botched nightmare that you then have to spend a week fixing nicely. If you see what I mean. Does that answer your question?
Yeah.
Cool. Anybody else?
Is there, in your opinion, an argument in the context of C# and Unity, which is white programming, is there ever an argument for having more than one, I guess what you'd call a root definition in any given file? Because sometimes you'll have a class defined in a file, but then someone will put like an enum alongside it or a mini class, and then before you know, you've got 3 or 4 different things all defined in one file, if you see what I mean, one CS actual file, and that can get confusing.
That's more of like a language logistics problem from C#, right? In that it sort of likes you to put everything in one file. So I use partial classes all the time, if that helps answer the question. Whenever I find that something, if you've got too much in one C# file, just make it a partial class and split it across several files. And then it's still one class, but it just means that you've only got so much complexity in each C# file, if you see what I mean. So I use that for a lot of things. All of my platform-specific code is written that way. So I have like a platform-common partial class, and then the platform-specific bits are partials of that only compile for the specific platforms. And there's a good reason for doing that in Unity specifically, because it means that you don't have to have... it'd be fine to use inheritance. A lot of people do. Like you'd end up like with my game manager _PS4, and it's inherited from the game manager. But I mean, first of all, I find it upsetting to use virtual functions when there's no need to, just at a weird OCD programmer level, that's me. But secondly, what that means is because in Unity you have to have, like your top level mono behavior is the thing that you can edit the values on, right? If you have an object that's got a bunch of values on it that you then have to new a thing that's platform specific while that thing's initializing itself, that's kind of clunky code, right? You end up with 2 files, 2 different types. You might have an interface to glue it all together, and it starts to get sort of cumbersome. So what I do is I just have one partial that's the main mono behavior, and then separate partials that have the platform specific code in. So I'd have like my game manager, and in Awake it would call platform on Awake, and then I'd have platform on Awake in each of in the partial classes. And so, there's an extra function call overhead, but the majority of that code is only going to get called once a frame, and with a bit of luck, the C# on compiler should just get rid of that call because it's always the same, and it's just literally one function. I mean, you can't promise because compilers, right? There's anybody who says, oh, the compiler optimized that way, just hit them, right? And it's not true, man. Sometimes it will, right? But unless they can prove to you that it will, don't believe them. Like that's the number of times I've had that argument and then proven that the person saying the compiler would optimise it was wrong. More than the ones I've lost.
Hi.
Hi.
Hey, when I was a student in university, in my programming classes, there were several lectures on UML diagrams and planning stuff out in class diagrams and use cases and all these things, and they were like, the lecturers were hammering that stuff in, like, you got to do it, you got to do it. And in my first company that I worked at with a couple of my friends, we were like trying to do that to improve our workflow, and we would like be annoyed when we didn't do it correctly, and we failed. And now I work at Media Molecule. It's the first proper games company that I've actually worked on, and like we're quite loose with development. And I'm wondering, like we often talk about how like rushing for deadlines and trying to get features in quickly leads to all this technical debt. Do you think this is endemic in games programming culture, or is it something we can fix?
So I don't think I don't think it's endemic I don't think it's endemic to programmers. I think it's endemic to the way that the industry is hit driven. I think that's the problem. Is ultimately like the people who are our bosses are there saying we've got to have this thing because the people who have given us money have said we've got a milestone with it, and that's kind of unavoidable, right? I think we're nearly done. Oh, can I just finish the question? Oh, rad. So yeah, it's endemic to the industry because we're hit driven and we've got all of this stuff, and it's like it entirely depends on how good the relationship is between your company and so like Media Molecule, for example, right? I know Alex a little bit and a few of the other people there. Like they've got a really good relationship with the people who publish their game, and if they say, oh, we're going to have to drop that feature because, then Sony will listen and say, okay, yeah, fine. Whereas if you're a work for hire developer who've promised to do 9 months of work and have all of these bullet pointed things, and then you don't produce them, the person who's checking your deadline list will go, no, you did not produce all the things. You cannot have the money. All your staff will starve. So it's not a simple answer. Ultimately, I don't think it needs to be endemic. I just think that people need to be more sort of upfront about saying, well, we'd like to produce. If you're ever in the situation where you're negotiating that, say we'd like to produce this. We can't promise you all of it, and you're going to have to understand if we don't, if you see what I mean, and just hope, or maybe just don't do deals with people who are unreasonable, I guess. Does that answer it?
Yeah, thanks.
And I think that's it. We are done.